Hi, welcome. I'm trying to learn particle physics. Today the symmetry of a standard model, and after we've done that, we're going to do ECU tendon training. The ECU tendon is here, and if you participate in the ECU tendon training, then it's at your own risk. Physics is now at the point where new theories are built on the assumption of a fundamental symmetry and an informed guess about what that symmetry might be. Unification is the holy grail of physics. The drive to develop theories that can describe everything in just a few, albeit possible outstandingly difficult equations. What sort of symmetry might unify the electroweak and strong forces we don't yet know, but the search for such a grand unified theory is an active area of physical endeavor. Okay, if we are searching for a formula or for a theory to describe the electroweak, and the strong force. A good grand unified theory might predict where all of the protons and neutrons in the universe come from. The total number of these baryons seems to be conserved too. Experimentally, we've tried to see if protons, the lightest of the baryons, can decay into anything. If we ever observe this, we will have some idea as to whether baryon number is really conserved. A key clue to a grand unified theory. Can protons not be destroyed? Can decay into anything? Protons cannot decay. So what is not decaying by radioactive material? Obviously not the protons. And the next thing is what was it? Or can they not? Imagine they cannot decay, because if a quarks inside of the protons would come further apart, they would get pulled with stronger force together. Maybe that is the reason why it cannot decay. That would be interesting. Of particular interest, as we look beyond the standard model, is supersymmetry, a model at the heart of many fledgling grand unified theories. Supersymmetry is based on unifying the two major groups of fundamental particles: fermions, the particles that make up matter, such as electrons and quarks, and bosons, including photons, the Higgs, and other particles governing forces. Okay, the two major groups of fundamental particles are the fermions and the bosons. The fermions are the electrons and the quarks, and the bosons are the photons and also the Higgs boson. It supposes that ultimately every fermion has a partner boson and vice versa. The two fundamental particles are fermions and bosons, and the supersymmetry theory supposes that every fermion has a partner boson and vice versa. You already see in the standard model there are 6 leptons, 6 quarks. There's symmetry. But why no 3? Why meet with 6 and 3? How many have your DNA? Maybe it's a coincidence. Hypothetically, exotics such as selectrons and Higgs. Oh yes, the partner of his fermions. They were selectrons and Higgs. If we find them, we're going to give them these names. Selectrons and Higgs. At sufficiently high energies, the supposition is that an electron and a selectron behave the same way, just as neutrinos and electrons behave identically under the weak force. Okay, the idea of a supersymmetry is that every fermion has a partner. That would mean that an electron, which is a fermion, has a selectron as partner. But these electrons seem not to be found yet. Supersymmetry neatly solves many problems of a standard model, as well as providing a motivation for why particles have the masses that they do. Okay, we have this idea of a supersymmetry. That the quarks are differently heavy, I think we mean them also here, because they're having a partner. In principle, that is, the Large Hadron Collider is hard at work looking for signatures of supersymmetry, but the lack of any success so far suggests we are barking up the wrong tree. Now we're saying we're having the Large Hadron Collider, for example, running, and it tries to find these electrons and the Higgs but I can't find them. And now we're getting the idea that we're on the wrong path. Even further away is the goal of folding gravity, that original object of symmetric study, and the forces covered by the standard model into a theory of everything. Indeed, physics is still far away from a final resolution. But in the thrill of the chase for better answers, it is studying symmetries that will guide us along the way. It is Eminer's theorem that allows us to magic useful physical insights from that. It allows us to magic useful physical insights from that. Whatever, I know what I mean. Now this was particle physics so far with that chapter. We're having a next chapter. So, we will continue somewhere with particle physics. If you're here for particle physics, you can go directly to the next part of particle physics. Then we will continue with particle physics. Here we will do now the ECU Tendon training. So if you stay and participate in the ECU Tendon training, then it's going to be on this. Arms next to us, gut, dass ihr das seht. Arms next to us, hands on the fists, and we bring the fists down. And up the floodgate. And again down. And now, the counterfeit money check. Fists and bring them up. And down. And we're having 3 rules. The first rule is that we're stopping immediately as soon as there's pain. The second rule is that we are not overdoing it. That's the third rule. So that we're not overdoing it. We just want to strengthen, not to exhaust. And we want to take a break to it. And the actual second rule is that we can't go only as fast as we can go with a little bit of effort. So last time down. I'm going to use no tennis racket. A tennis racket is light, it has just around 300 grams. So whatever you use as a dumbbell, do it in accordance with our 3 rules. Take the elbow in, take the lower arm, so that you're moving just with the wrist and the lower arm. And we're on one side, and slowly over to the other side of the mannequin. Last time. Now with long arm out and over to one side. And over to the other. Middle and over the other. Small arm in and over to one side and over to the other. And last time. No, no. And now next exercise, take a regular well from top, lift the arm up, once over, and back in, harvester walk. Down and another time. And now, the palm facing upwards, the garbage trucks grab up. And the same time. And on the other side. Now with palm facing upwards. And you can also use instead a towel or a t-shirt. Just press with good force onto it, and then bring the rest up. And again down. Up. And last time down. Up. Now the other side. Press with good force, bring the wrist up. And down. Up. Up. And one last exercise, just press with good force onto it. And on the other side. And that was the ECU Tendon. I thank you very much, and until next time.